All right, so can people tell me what similarity means? We looked at it last term. We were doing like volume and all those sort of things. Similar shape, similar, what were they? What can you remember? Pardon? They have similar dimensions. Similarity. Good, they've been enlarged by a certain amount. Okay, so we had, can you remember what letter it was? K. So we had this, if shapes were similar, all the lengths were enlarged by the same amount. That's what the way that the word that is called is that it has like a similar ratio to each other. So all the different lengths have a similar ratio. Pardon? A scale factor. So a scale factor. So every single length has the same scale factor, okay, or the same ratio between them. Now that works for 2D shapes. It also works for 3D shapes. So if a 3D shape was similar, all the lengths of that 3D shape would have the same scale factor. So for example, if we just drew like, if it was working, okay. If I drew like a triangular prism, and I had all the sides here were 4 centimeters, and this side here was 10 centimeters, this shape would be the same, would be similar if this was 20 and this was 8 centimeters. What is the scale factor for this? So K equals 2, okay? All lengths are in the same ratio. Now, what about if we look at this? What about the angles here? Like if we think about this triangle, it's an equilateral triangle. What would be the angles on that triangle? 60, okay? So this was 60 degrees, 60 degrees, 60 degrees. Now, that's because an equilateral triangle, all the angles are the same. Now, what about in the scale factor, so the similar shape, but it's all been multiplied by 2? Are they 120, 120, 120? No, because all angles in a triangle add up to 180. So what are the angles of this triangle? 60, 60, 60. Okay, so this brings us to a rule, okay, for similar shapes. This goes for both 2D and 3D. Okay, if two shapes are similar, all lengths must be in the same ratio. So that's what we call our scale factor, or K. Okay, all the same thing. Ratio, scale factor, K all means the same thing. And it can't be just one, it has to be both of these rules. And what do you think is the rule about angles? Good. All corresponding angles are the same. Bryce, you okay? Can you write it down, please? Now, if we need to prove this, we have to show how we prove it. So there's a particular way to show that two shapes are similar. So last term when we did similarity, I always said the two shapes are similar, and then you did those rules, okay? This time I might give you two shapes and I might say prove that they are similar, okay? So if I tell you we need to prove that two shapes are similar, what do you think we need to do? We need to show that the corresponding lengths are in the same ratio, so, and that the corresponding angles are the same, okay? So this is how we need to be able to do that, okay? Now, the symbol for similarity good if I could spell, is, it just looks like a little one line curly line. So you need to know that. Okay, so proving two shapes are similar. I'll give you an example. So the question would be, are these shapes similar? Or prove these shapes are similar? I'm just going to use an equilateral triangle, not an equilateral triangle, an isosceles triangle. All right, so are these shapes similar? Yes. What's the scale factor? 3. All right, so we know that straight away. However, if I asked you to prove it or show why they're similar, we need to do a particular set of working out to show that. Okay, so you could say, yes, K equals 3. Now, if I then said, so that's part A, if I then said, prove it, prove they are, we have to do something in particular. So if I have to prove they are, what do I have to prove? Georgia, can I just get you to shut your computer? Yeah. Angles are all the same. So I need to see how all of these have letters next to them. I need to prove that the angles are the same. Now, it has to be corresponding angles. So what angle corresponds to A? F. So I'm going to say angle A is equal to angle F. You have to use an angle sign, okay, which is what that little like L looks like. So I've done that. I've said angle A is equal to angle F. What else do I need to do? Yeah. Good. Angle B is equal to angle H. Now, be aware, sometimes the triangles are like spun around, so you still need to find the corresponding one. They're not always perfectly drawn like I've drawn them where they're exactly linking up. So you need to look at where they are. What's the last line of this bit? Angle C is equal to angle G. Okay, so we've got the corresponding angles are all equal to each other. What else do I need to do? The sides. Okay, so we need to be able to say, how do I write a side like the side on the left of the left-hand triangle? How would I name that side? AB. Okay, so I'm going to say that angle AB is in the same ratio to, where's the corresponding one to AB? What if I wrote HF? No, they have to be in the same order. Okay, so you have to work out the corresponding ones. Sometimes the way to work it out is actually use a highlighter. You guys know I love a highlighter. I would just highlight them and then make them corresponding. So highlight the A and the F, that's corresponding. The G and the C is corresponding. And the H and the B is corresponding. And that way you're not going to get confused and put them in the wrong order because you know which ones are corresponding. Okay, so AB is in the same ratio as, what did we say? FH. Okay, and that is equal to what ratio? It's not just 3, it's 1 to 3, okay? 1 to 3. So the ratio of A to B to F to H is 1 to 3. Okay? Then I'm going to go B to C. The ratio from H to G is equal to 1 to 3. And then the angle from A to C, the ratio, not angle, the side AC is in the same ratio as F to G, and it's 1 to 3. So that this way we're actually I'm showing you that all the angles are the same. Not the same. All the angles are the same. All of the side lengths are in the same ratio. So therefore the two triangles are similar. So therefore is a triangle with a dot, 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 like that. Triangle with dots. That means therefore. Therefore, triangle, what do you reckon symbol we use for triangle? A triangle. Triangle ABC is similar to, what sign do I use for similar? Squiggly line. Triangle, same order, so yellow, green, blue, so FHG. That's how we prove it. You need to prove that all the angles are the same. You need to prove that all of the side lengths are in the same ratio. And then we need to say, therefore, they are similar to each other. Does everyone feel like they can do that? You can do the same thing with a 3D shape. There's just more lines to be able to say they're all the same. Any questions about that? Nope. All right. We're just going to do a whole heap of different questions now. And tomorrow we'll do just similar triangles and the rules for similar triangles. And then we're kind of finished with similarity. So just that's going to be it. Okay. So what I'm going to do is I'm going to give you some questions from both exercise 10B and 10C. And I'll come around and help you as you need it. All right. So exercise 10B. This is still book 1. Exercise 10B. I'd like you to do, hang on a tick. Let's go with questions 1 to 3 and question 5 and then exercise 10C. Just hold on. Yes. Questions 1 to 14. They're not too long. And we've got a heap of time. Any questions? All right, get started.